All right, welcome to 2.7. We're going to talk about absolute value functions today. In our central question, how do you graph absolute value functions? And when we think of absolute value graphs, they're shaped like V's, just like value. Okay, so they look like this a little bit. Okay, so an absolute value function would look something a little bit like this. Would be like f of x equals the absolute value of x. That's kind of the basic parent graph, the basic function, just absolute value of x. Okay, and remember it's a V shape for value. Okay, it will in its base shape will never go negative because you can never have a negative absolute value. Although we can adjust it so that it is negative, and you'll see what I'm talking about here in just a little bit. All right, so we have an axis of symmetry, and that is a vertical line that goes through a vertical line, and it goes through the vertex. Okay, now what is the vertex? It's our maximum or our minimum. So basically it's the point of the V. So this star down here, this would be your vertex. And then this is your line of symmetry, right here. It's a vertical line, it goes through the vertex. Okay, it's basically splitting your V in half. All right, so our parent function, like I was talking about, f of x equals absolute value of x. If we plug in 3, we're going to get out positive 3. If we plug in 2, we're going to get out positive 2. If we plug in negative 1, we're going to get out 1. If we plug in 0, the absolute value of 0 is 0. And then absolute value of 1 is 1, of 2 is 2, and of 3 is 3. Okay, now we can plot these points. And so we have our vertex is at 0, 0. And then we have 1, 1, negative 1, 1, 2, 2, 3, 3, and it's symmetrical. Okay, and it's coming out from here. Remember your arrows because it's going on forever and always. Okay, and if we wanted to draw our axis of symmetry, it would be, whoa, let's redo that. It would be your, whatever. That would be your axis of symmetry, the y-axis. All right, so we can change this graph. We can change it around. If we go back, if we notice our slope here, we have a slope of 1. Just pointing that out. Here our slope is 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. All right. On this side, though, then it would be a slope of negative 1, right? Down 1 over 1, down 1 over 1. So they should have the same slope. They'll just be opposites of each other. All right. So like I said, we can transform a graph. If we wanted to shift it up, I'm just going to use y equals, because that's what our basic graph was here. If I wanted to shift it up, I'm just going to add or subtract a number. So for up, I'm going to add it, and let's just say I go up 3. Okay. If I want to go down, then I would subtract a number, so subtract 2 or something like that. Okay. If I wanted to move to the left, now this is where it gets a little tricky, okay, because these two, the numbers are outside of our absolute values. Okay, if we want to go left and right, we're going to put them inside our absolute values, and it's backwards of what you think it should be. Okay, so if I want to go left, I'm going to add a number, so let's just say 4. So that would be left 4. If I want to go right, then if we're using our deductive reasoning, then I'm going to have to subtract a number. Okay, so these are backwards of what you think they are. If we're going left, we're adding. If we're going right, we're subtracting. And that's probably the big sticking point for a lot of people, is that they forget about that. For here, I mean, up is +3 and down is minus, so like these ones are fine, but the left and the right, those are the ones that are backwards. All right, so if we wanted to stretch it, we want a number bigger than 1. Because right now, with our parent function, this is really 1 times absolute value of x, right? So if we want to stretch it, that means that we want it to go up faster than it normally would. We're going to add any number bigger than 1 here. So we could add 5. It would go up really fast there. Okay, so 5 times the absolute value of x. If we wanted to compress it, and compress means like to squish it down. Okay, so stretch is like you're taking the top of your graph and you're just like pulling it upwards, and so then it comes together, right? Compression would be like you're putting your hand down and you're squishing it. So I'm going to put the word squish here. Okay, it's that concept of pushing it down, and so it's going to be a wider graph. Okay, and in order to do that, we're going to have a number less than 1. So for example, 1/3. That just means they're going up 1/3 as slow, or 1/3 as fast, so not quite as fast. Okay. Now I said earlier that it's always going to be positive, but there are ways that we can change it to make it negative, and this is that way. So if we want to reflect across the x-axis, if we want to make it upside down, we're going to do y equals negative absolute value of x. Okay, that just, because anything in here is going to be positive, and then you have your negative sign hanging out here to make it negative. If we want to switch over the y-axis, so if we wanted to do, if we wanted to reflect over the y-axis, not quite as useful, but we're going to put it in there. Now, this one's not doesn't have a whole lot of use because it's symmetrical anyway. But there are times where if we have shifted it already, so maybe we've moved it, over to the right a couple, and then we reflect across the y-axis, you're going to get changes. Just in its parent state, this doesn't mean much. But if you're shifting it over, then it's going to take on some changes. Okay. One last thing about the squishing: it has to be less than 1, but it also has to be greater than 0. We can't have a negative number. Well, we could have a negative number, but then it's going to be more than just compression. Okay, so it's got to be bigger than 1, less than, or bigger than 0, less than 1. Okay. So we're going to graph the absolute value function of this, and then we're going to we should graph the parent function right away, so we'll do that. That one was here, 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 here. The parent function starts at the origin, the slope of 1 and then also -1. Let's see if we get some lines here, so that's actually straight. Okay. Okay, so that's our parent function, and now we're going to plot our points. Now, my suggestion, if you're ever confused, is to just make a t-chart and just start plugging in numbers. And so we're going to plug in 0 right away. That's easiest. So absolute value of 0 is 0, plus 3 is 3. Okay. And really, if we look at this, what are we doing to it? We're just taking this graph, and what are we doing? We're shifting it up 3. Okay, so 1, 2, 3. Okay, so now we should have 1, 4. Let's just check and make sure we do. 1, absolute value of 1 is 1, plus 3 is 4. Yep, so all these points are just shifting up 3. Up 3, and then here, here, and here. And then we connect our lines, obviously. Okay, so how is it different than the parent function? Well, it's just shifted up 3. So in your homework, if it asks that, you're just going to say up 3. All right, so which of the following is the graph for x plus 3, absolute value of x plus 3, and then minus 1? Well, if we break this down, we know that the minus 1 will shift it down 1. And then this plus 3 in here, what does that mean? It means we're going to shift it left 3. Okay, so this is left 3. Okay, so we have our parent function, which would be on the origin. We'll just go A, B, C, and D. So A, we're supposed to go to the left 3. Well, this one goes to the right 3, so this one's a no. B, we go to the left 3, 1, 2, 3, yep, and then down 1, so this would be it. This one is to the left 3 and up 1, that's not what we need, and then this one's to the right 3 and up 1, definitely not what we need. Alright, last couple things here, I gotta speed up a little bit. Vertex form, general vertex form. Actually, let's make 2 parts to this video just so that I can make sure I get it all in.